Chapter 7 Cognitive Perspectives, Metacognition and Problem Solving, Part 2 by Denjami Barker, Myra Bernal, and Wendy Rivas. In this part, we're going to be talking about problem solving, the prior research, the types of problems, and sub-processes for problem solving. Problem solving is defined as the process of finding solutions to difficult or complex issues. The solver will be working through details of a problem in order to reach a solution. Original research, however, wasn't really focused on the educational aspects. They were looking more for simple development of problem-solving strategies, and they assumed that they could transfer those strategies into more domain-specific strategies. However, they found out that they couldn't. So in the 1990s, the research focused more on school curriculum, and it focused on learner interpretation, structuring, and adapting of knowledge into new solutions. Prior research included GPS, heuristics, AI research, and ACT-R theory, which we'll talk about a little bit more later. The GPS worked for well-defined problems, and it consisted of three main steps. The first was to represent the problem, the givens, and the lead operators. The second step was to establish goals and sub-goals, and from there you would begin solving for those sub-goals. The third step was using mean-ends analysis to assess progress and redefine goals. So what mean-end analysis was is that they would assess the differences in the present state and the desired state and look for operators in order to reduce those differences and go more towards the desired state. And they would also evaluate the results. It was, like I said before, good for well-defined problems that had clearly defined sub-goals, but they later found out that problem solving in the real world did not necessarily have defined goals or weren't well defined. Heuristics was very much like GPS, where it worked well for well-defined problems. And in this aspect, the solvers worked backwards. So they worked from the goal towards the givens, the original givens. They also used a hill climbing method where they would take any step towards the goal, but the steps didn't necessarily help you reach the goal. And they also divided problems into sub-problems to see if they could simplify it a little bit better. They would also search for memories for similar problems or analogies that they could adapt into, that they've used previously into a new problem that they're encountering. However, one difficulty with heuristics like the GPS is that most problems require domain-specific information, and both GPS and heuristics did not address these key thinking processes. Artificial intelligence research wanted to use and understand intelligence by using and building computer programs, and they studied the programs that the world presents to intelligence. However, there was one concern where the tasks that were easiest for the computer to solve were often most difficult for humans, and vice versa. Tasks that were easy for humans to solve were ones that were very difficult for computers to solve. In the ACT-R theory, also known as the adaptive control of thought and rationale theory, knowledge is represented into two memory systems. The declarative memory, which was where the memory would store facts, and procedural memory, where the memory would store rules. And cognition is a result of the interaction of several different modules. And those modules included visual, problem state, control, declarative, procedural, and manual. These modules can act on information at the same time. However, one limitation is that each can only deposit a little information at a time into the buffer associated with the model. So what Act R defined learning was defined learning in terms of the retrieval time of information and the compilation of production rules. However, it doesn't account for learning of the individual production rules prior to their compilation. Now, the different types of problems, they have three main components: givens, goal, and allowable operators. For the given, this included elements, relations, and conditions that kind of help initiate the problem. So it would pretty much set up the solution, or set up towards going to the solution. The solution was the goal. The goal was any desired outcome or solution, and the allowable operators were the steps or procedures that will help you transfer from the given to the goal. However, one obstacle that was faced is that many students had difficulty transferring for the student to transform the initial form of the problem into the desired outcome. So in other words, when they read the problem or encountered the problem, they had difficulty finding out the given, or figuring out how the givens could be used in order to reach the goal. There is a difference between well-defined and ill-defined problems. Well-defined problems are more computational problems such as multiplication, addition, subtraction, and such. And those type of problems have all three components: the given, the goal, and the allowable operators are very explicit, are given, or are readily available for the solver. Ill-defined goals are where the components are not immediately clear to the solver. They had very open-ended questions, and these were more geared towards real-world problems. Real-world problems don't have a set of steps that you can follow. You have a problem, you have a set prior knowledge, or maybe practice on similar problems, but you pretty much have to find a solution on your own without being given a set of steps. You also have routine and non-routine problems. Routine problems are going to be problems that the solver has already recognized, or past problems that they have used. This is kind of coincides with reproductive thinking, where the solver already has experience with solving similar problems. Non-routine problems are problems where the solver has never previously encountered, or they cannot go back to prior knowledge and access a pre-existing solution. And this coincides with productive thinking, where the solver has to completely construct a new solution. These sub-processes in problem solving includes representing the problem, planning, overcoming obstacles, and executing plans. In representing the problem, the solver has to identify the most relevant features and create a mental map. That mental map will help the learner organize conditions and decide on steps in order to go towards the goal, and help keep track of the progress. The planning stage is where the learner will anticipate any problems, and in order to avoid any mistakes, they're going to look for plans and strategies and steps or procedures in order to solve the task. Overcoming obstacles is where the learner will look into prior knowledge in order to see if there is any information that they can use in order to help solve the problem. They can also kind of take a break, in order to allow thoughts to kind of mull around in their minds and maybe give them a little bit of a break in order to find a solution. The second is executing plans. They will monitor their progress, and they will this kind of helps prevent misapplication of steps. So they will kind of self-assess where they currently are, where they want to be, and what steps they need to take, and if they are taking the right steps. Expert and novice problem solvers are different in three different ways. The time period for expertise development, knowledge differences, problem representation, problem approach, and self-monitoring skills. In terms of the time period, an expertise has to have time in order to develop. It's not something that can be done hastily. It takes a little bit of time, and it was given to us that expertise can take anywhere from 5 years to 10,000 hours in order to develop. Knowledge differences is where the expert are going to have a more organized knowledge around the phenomena in relation to higher order principles. So they can see a phenomena occur, they can relate it to a higher theory. And they do this by having more effective encoding skills. They are using their short-term and long-term memory more effectively by chunking their recall. And they have more practice in encoding and finding solutions. They effectively use problem solution strategies, and it makes it kind of automatic because they have a lot of knowledge and a lot of practice with this. However, novice are going to organize their knowledge around main phenomena. So they will see a phenomena happen, and they will kind of look at it and just see the main phenomena without thinking higher, what could be the larger theory in place. And they're going to rely more on rote memorization skills because they do lack that the practice of encoding and finding problem solution strategies. Problem representation is more used by experts, where they will construct representations, drawing, or depictions in order to help them find the solution. They will then be able to divide problems into more simple or basic principles that they can then easily solve through if the task is more abstract. Problem approach. The expert will work a problem out from the given to the solution. So they have a set order in which they do work through a solution, and they search for problems, or they construct explanations, and they search for patterns of knowledge. The novice are going to work backwards. So they're going to see a goal, and they're going to attempt to work from the goal towards the given. They don't notice any discrepancies. For cognitive skills or self-monitoring skills, the expert's going to take more planning in self-monitoring. So they're going to look inwards more, see if they are understanding the problem, if they are using their steps or the procedures effectively going towards the goal. Novice, they're going to use the self-monitoring less frequently, and they are not going to have an awareness of the errors, and they don't have they don't check for solutions or as frequently, or if they're going towards the solutions properly. This has been part 2. for the problem solving aspects of chapter